පේපර් 26කද okay, so we finished measuring instruments last week. We finished measuring instruments last week. මිනුම් උපකරණ ගිය සතියේ ඉවර කරා. Okay, so focus everyone. I think everyone is here now. Okay, so we finished measuring instruments last week. මිනුම් උපකරණ ගිය සතියේ ඉවර කරා. But I mean it's not over completely. I uploaded past paper tute to the for the measuring instruments in the group. මිනුම් උපකරණ past paper tute group එකේ දාලා තියෙනවා. So I'll take like 3 Fridays online 8 to 10 p.m. as I think that was the time, right? 3 Fridays 8 to 10 p.m. 3 or 2 Fridays 8 to 10 p.m. online. I'll discuss measuring instruments and units and dimensions past paper questions. Okay, that is the plan. So I'm starting mechanics today. මම අද යාන්ත්‍ර විද්‍යාව පටන් ගන්නවා because were in a hurry to start mechanics. That was my plan so that we can finish a significant amount of content before term tests. But measuring instruments, the lesson is not over. මිනුම් උපකරණ පාඩම ඉවර නැහැ. Please try to finish the past paper questions from measuring instruments tute. I'll be doing past paper questions and some other questions from that area from measuring instruments for like 2 or 3 weeks, Friday 8 to 10 p.m. Tutes, okay. I'll ask him sir to give the tutes, but for now you can like just follow what I'm teaching. So, and giving a brief description about the classes, I think. Yeah, I think everyone's here now. Giving a brief description about the classes, there are 2 classes for 26 batch. Sunday morning 8 to 11:30. Wednesday evening 3 to 6:30. This week, Sunday morning class, I'm starting coplanar forces. ඒක බල පටන් ගන්නවා ඉරිද පන්තියේ මේ සතියේ. And today in this class we are starting mechanics and about 2 classes. Like in 20 Sunday class there are around physically there are around 90 students, but altogether there are like 150 students in the Sunday class. Here we have around online and physical we have around 40-50 students. So if you need a smaller class you have to be here, but if you need a highly competitive class you have to be in the Sunday class. And also the mode of teaching, I'm explaining a lot. Here I'm explaining a lot in English, okay, but in the Sunday class ඉරිද පන්ති මම සාමාන්‍යයෙන් වැඩිපුර සිංහලනුත් කතා කරනවා English terms එක, but this class specifically started due to the need of like speaking English because there were some students in the Sunday class who couldn't understand Sinhala. So that was one reason to start this class. So here I'll be explaining stuff in Sinhala, but mostly I'll be using English in this class. So that is the usual plan, usual idea about 2 classes, but I'm trying to match this class and that class as soon as possible because for the Sunday class we have a weekly paper. There are a lot of programs going on in Sunday class. So when we do a significant amount of content in this class, we can quickly move to that plan. So you will be getting a weekly paper. And also something to add, this may not be the only class you are joining, okay? Definitely, because I started this class a lot late, so this may not be the only class you are joining, but if you are joining at this class or Sunday class, if you like, you can write the Sunday paper too, Sunday class paper too. There you get questions up to Newton's law, clear? If you have learned up to Newton's law, you are getting a Sinhala medium paper, a complete Sinhala medium paper and an English medium paper. So if you are joining, and you can pay for one class, okay? You can pay for one class, and if you like, you can join both classes, okay? Both Sunday or Wednesday classes if you like. And also, if you like, you can, soon I'll be starting the Wednesday class paper, Wednesday class weekly paper, soon I'll be starting. But if you have learned up to Newton's laws from somewhere, from school or from another class or anywhere, then if you like, you can write the weekly paper here at the institute or online, weekly paper of Sunday class, okay? So if you like, you have to pay for only one class, but if you like, you can join both the classes, and if you like, you can write both papers from Sunday class and Wednesday class, clear? Okay, things to remember. So like, definitely my recommendation is, if you have learnt more than this point, definitely most of you guys may have learnt up to Newton's law, right, by now. So if you have learnt up to that point, like, feel free to write my weekly paper for the paper that I give for the Sunday class, clear? Let's do it that way. And I'll give access for marking schemes and everything for you guys also, but don't write both papers, because I mean, some papers may be repeating for you guys, so choose one paper, choose one set, okay? If you like, you can keep writing Sunday class paper, or if you like, you can keep writing Wednesday class paper when I make it available, clear? Okay, I'll pass all the messages again after the class, okay? For now, let's start the class. Today we are starting mechanics from vectors. අපි දෛශික වලින් තමයි පටන් ගන්නෙ. Okay? And even if there are Sinhala medium students, I don't think it's a huge problem, because as I explained, S equals UT plus half AT squared have no language. F equals MA doesn't have any language. So physics, like, usually physics is not bounded by a language. So I don't think that it would be a huge issue. So I'll start. Focus here. හැමෝම අහගන්න. Vectors and scalar quantities. දෛශික සහ අදිශ රාශි. What are vectors? What are scalars? මොනවාද දෛශික, මොනවාද අදිශ වෙන්නේ? The rough idea is, assume this thing. Think that someone asks you for the direction. Someone asks you for the direction. You'll be getting tubes and cards will be marked, but keep your focus here, okay? Sometimes, like, someone asks you for the direction. If you ask them to move 500 meters, it's pointless, right? Meter 500ක් යන්න කියලා වැඩක් නැහැ නේද මිනිහෙට. If you ask someone to move if he asks for the, like, how to go to this supermarket, okay? If the question is how can I find this supermarket, there's no point of telling move 500 meters. Meter 500ක් යන්න කියලා තේරුමක් නැහැ නේ. You have to specify the direction, okay? Where to turn, which direction, move this way, then move this way, clear? So some physical quantities are pointless without the direction, clear? සමහර භෞතික රාශීන් වලින් ඇති වැඩක් නැහැ එයාගේ දිශාව ස්පෙસિෆයි කරන්නේ නැත්නම්. තේරුණාද? Some physical quantities are pointless without the direction, clear? These kind of physical quantities which are meaningless without the direction, we call them vectors, clear? දිශාව දැනගන්න නැතුව මොනවා කිව්වත් තේරුමක් නැති භෞතික රාශීන් වලට අපි කියනවා දෛශික කියලා. තේරුණාද? And scalars, when you mention your mass, clear? When you mention your mass, like 50 kilograms, you don't have to specify a direction, right? So some physical quantities have a good meaning, a very fine meaning without the direction, clear? දිශාව නැතුව හොඳ meaning එකක් තියෙනවා සමහර භෞතික රාශීන් වලට. තේරුණාද? Clear? Okay, so you can get the tubes from Himsara. And for online students, tubes are available in the group, but if not, I'll upload them to the group and to the Zoom chat again, okay? Now, there's a question. Okay, when do we have the Sunday weekly paper? I'll give all the notices again in the after the class, okay? Today I'll give all the notices again. Okay. And thinking about starting a paper discussion for 26 batch 2, but still we are planning on that. Now, so that is the basic idea of a vector. පැහැදිලි ඉන්නේ හැමෝටම දෛශිකයක් කියන්නේ මොකක්ද කියලා. Something which is meaningless without the direction. දිශාව නැතුව තේරුමක් නැති භෞතික රාශියක්. Clear? Now, how do we represent a vector? How do we represent a vector? You don't have to write anything. Everything is available in your notes. So use that focus to keep to learn. Okay, that's why I usually don't ask you to write when I'm teaching, because like I need 100% focus when I'm teaching. So now, how do we represent a vector? දෛශිකයක් කොහොමද නිරූපණය කරන්නේ? It's simple. This is how you graphically represent a vector. This is how you graphically represent a vector. දෛශිකයක් රූපමය වශයෙන් නිරූපණය කරන්න මෙහෙම. This is how you graphically represent a vector. A may be the starting point of the vector. B may be the finishing point of the vector. දෛශිකය පටන් ගන්න A වලින් ඉවර වෙන්නේ B වලින්. මල්ලි tutes. Okay. Now, this is the graphical representation of the vector. This length of this arrow, it represents the magnitude of the vector. Clear? How many meters do you have to move? Clear? This magnitude, this length, it represents the distance or the magnitude. Clear? Magnitude of the vector. දෛශිකයේ විශාලත්වය තමයි මෙයාගේ දිගෙන් නිරූපණය වෙන්නේ. Clear? Then what about this direction? It represents the direction of the vector. ඒක නිරූපණය කරනවා දෛශිකයේ දිශාව. තේරුණාද? Okay. Now, how do we write this vector? A vector which is moving from A to B. Clear? Vector which is moving from A to B. This is the written expression of the vector. මේ තියෙන්නේ දෛශිකය ලිව්වම අපි ලියන්න ඕන විදිය. තේරුණාද? And also, instead of using AB, you can give a single name for this vector. මේ දෛශිකයට තනි නමක් දෙන්න පුළුවන්. Like A. But simply A means just a variable. So to represent that it is a vector, you have to draw a small line here. Now we know this is a vector called A. When someone sees this, they know that this is a vector called A. මේ ඉන්නේ A කියලා දෛශිකයක්. තේරුණාද? This is a vector called A. Clear? එහෙනම් මෙන්න මේ විදිහට අපිට දෛශික නිරූපණය කරන්න පුළුවන්. පැහැදිලිද? Okay. Now we have something called the negative vector. Negative vector. ඍණ දෛශිකය. What is negative vector? A vector with the same magnitude but opposite direction. මේ විශාලත්වයම තියෙන හැබැයි දිශාව ප්‍රතිවිරුද්ධ දෛශිකයකට අපි කියනවා ඍණ දෛශිකය කියලා. තේරුණාද? A vector which has the same magnitude, clear? Same length but opposite direction. Clear? Opposite direction. ප්‍රතිවිරුද්ධ දිශාවට යන්නේ. පැහැදිලිද? Clear? So this one we can write as, if you like, minus AB. Negative vector of AB. Clear? But if you like, you can write it this way. Actually, this negative vector is moving from B to A, right? This negative vector is moving from B to A. මෙයා B වලින් ඉඳන් එට නේ මේ ඍණ දෛශිකය යන්නේ. So if you like, you can write BA. Instead of writing minus AB, you can write BA. Clear? BA. And also you can write minus A. Why? A was this vector. This is the negative vector of A. Clear? මේ විදිහට ඍණ ලකුණක් දාලා මෙයාගේ සිම්බල් එකට දාලා ලියන්නත් පුළුවන් ඍණ දෛශිකයක්. පැහැදිලිද? Clear? Okay. Now next step. I'm going to teach a lot of stuff, then I'll be moving to questions. Otherwise, for each small theory part, you have separate exercises. Exercise 1, 2, 3, 4 like that. But I'm not going to do those exercises. First I'll teach enough content, then I'll move to questions. So here, this one. Now, next first, like we learned about number. අපි ඉලක්කම් ගැන ඉගෙන ගත්තා 1 2 3 4. Then what was the next step? How to add numbers, how to subtract numbers. ඉලක්කම් එකතු කරන්නේ කොහොමද, අඩු කරන්නේ කොහොමද? Same thing. After learning about vectors, what you have to do is learn how to add vectors, subtract vectors. Clear? So now we have to learn how to work with vectors. දෛශිකයක ගනුදෙනු කරන්නේ කොහොමද කියලා අපි ඉගෙන ගන්න ඕනේ. තේරුණාද? So first thing, how to add vectors. vectors දෛශික එකතු කරන්නේ කොහොමද? Clear? How to add vectors. There's a rule called vector triangle law. දෛශික ත්‍රිකෝණ නියමය. Vector triangles. What is the meaning of a vector triangle is basically what is the meaning of a vector summation? දෛශික එකතුවක් කියන එකේ තේරුම මොකක්ද? If some person moves 500 meters this way and 200 meters this way, okay? If this is vector x, if this is vector y, what is the final vector which occurs as a result of these two vectors? මේ දෛශික දෙකේ ප්‍රතිඵලයක් විදියට ඇතිවන සංප්‍රයුක්ත දෛශිකය නේද මේ දෛශික එකතුව කියන්නේ. What is the final vector which occurs as a result of these two vectors? මේ දෙන්න ඇතිවන තනි දෛශිකය. So this is the vector, right? This must be the resultant, right? If someone moves 500 meters this way, 300 meters this way, this is the actual displacement. This is the actual path that he travels, right? Clear? At the end of the day, this is what happened, right? This is what we call the resultant vector. මේකට අපි කියනවා සංප්‍රයුක්ත දෛශිකය. මොනවා හරි දේවල් කිහිපයක් වුණා නම් ඒකේ ප්‍රතිඵලය විදිහට මේකේ වෙන්නේ මොකක්ද කියන එක. පැහැදිලිද? Okay. Now, next part. So, the rule. Now you can already see the rule. You can already understand the rule. What is the rule? We can call it a vector triangle. මේකට අපිට දෛශික ත්‍රිකෝණයක් කියලා කියන්න පුළුවන් නේ. We can call this a vector triangle. Why? See, it creates a triangle. Clear? It creates a triangle. So, vector triangle law means දෛශික ත්‍රිකෝණ නියමය කියන්නේ if you represent two vectors as two sides of a triangle, okay? If you represent two vectors as two sides of a triangle, resultant can be obtained by completing the triangle. Okay? මොකක්ද? ත්‍රිකෝණයක පාද දෙකකින් දෛශික දෙකක් නිරූපණය කරනවා නම් ඒ ත්‍රිකෝණය සම්පූර්ණ කරන්න අඳින්න ඕන රේඛාවෙන් ඔයාට සංප්‍රයුක්තය ලැබෙනවා. Clear? Clear? If this is vector x, if this is vector y, okay? You draw two sides. You represent x and y as two sides of a triangle. ත්‍රිකෝණයක පැති දෙකක් විදිහට x y y y අඳිනවා. Now you have to draw this line to complete this triangle. මේ ත්‍රිකෝණය සම්පූර්ණ කරන්න මෙතන ඉඳන් මෙතනට ඉරක් අඳින්න ඕනේ. This line we call it the summation of x and y. Clear? ඕකට අපි කියනවා x ගේ y ගේ එකතුව කියලා. Clear? So vector triangle law is really simple. You have to represent two vectors as two sides of a vector, then you get the resultant. Clear? Sides දෙකකින් පැති දෙකකින් දෛශික දෙකක් නිරූපණය කරා මේකෙන් මට සංප්‍රයුක්තය ලැබෙනවා. Clear? Okay. Now next part. This is a triangle, but triangle works with only two vectors, right? And online students, if you have any questions, please let me know. Okay? Please let me know if you have any questions. Now, the problem is you can work only with two vectors here, right? දෛශික දෙකක් එක්ක විතරයි නේ වැඩ කරන්න පුළුවන්. But definitely there are instances that you have to work with multiple vectors, right? Not one, not two, maybe 100. Okay? For that we use vector polygon law. Yeah? දෛශික බහුවශ්‍රය use පාවිච්චි කරනවා. දෛශික ගොඩාක් එක්ක එකපාර වැඩ කරන්න ඕන වුණාම. තේරුණාද? So how do we use the vector polygon law? What is vector polygon law? මොකක්ද දෛශික බහුවශ්‍ර මූලධර්මය කියන්නේ? It's really simple. Assume that you have vector x. You have vector x. You have vector y. You have vector z. Vector x, y and z. There are three vectors. දෛශික තුනක් තියෙනවා මේ විදිහට. Okay? You draw vector x. You draw vector x. Then you draw vector y. ඊළඟට y දෛශිකය අඳිනවා. You draw a triangle to get the resultant. You draw a triangle to get the resultant. So this is the resultant, right? This is the resultant. This is x plus y. This is x plus y. Triangle x plus y. මේ තියෙන x ධන y ත්‍රිකෝණය. x ධන y දෛශිකය. Now you add this vector and this vector. You add this vector, this one and this one. Now again you can draw a triangle, right? ආපහු ත්‍රිකෝණයක් අඳින්න පුළුවන් නේ. Clear? You start with this vector, x plus y vector. Clear? x ධන y කියන දෛශිකයෙන් පටන් ගන්නවා. You start with x plus y vector. Then you draw z vector. Then you draw z vector. So x plus y z. Then what is the result of this triangle? What is the result of this triangle? This is the result of this triangle, right? Now you have to understand, although we used two triangles for this, okay? Although we used two triangles for this, what actually happened was I was drawing a polygon, right? මම මෙතන එක ත්‍රිකෝණයක් ඇඳලා ඊට පස්සේ තව ත්‍රිකෝණයක් අඳිනවා. හැබැයි මම ඇත්තටම කරේ මොකක්ද? මෙතනින් මෙතෙන්ට මෙතනින් මෙතෙන්ට මෙතනින් මෙතෙන්ට බහුවශ්‍රයක් අඳින එකනේ. Okay? I used two triangles, but what actually happened was I'm drawing a polygon, right? Clear? So if you need to work with multiple vectors, okay? If you need to work with multiple vectors, represent each vector as a side of a polygon. Okay? Represent each vector as a side of a polygon, and the line that you have to complete, that the line that you draw to complete the polygon is the resultant. Clear? බහුවශ්‍යක පැති වලින් නිකම් මේක ඇඳගෙන යන්න මේක සම්පූර්ණ කරන්න ඕන රේඛාව තමයි සම්ප්‍රයුක්තය. Clear? It's simple like that. Clear? You just have to represent these all the vectors as sides of a polygon. Clear? දෛශිකයක මේ polygon එකක බහුවශ්‍යක පැති විදියට ඇඳගෙන යන්න තියෙන. තේරුණාද? Okay. Next we have to move to vector parallelogram law. But before that, move to exercise 2. Exercise 2 of your note. I'll provide the tut in the group. Exercise 2. Try question number 2, exercise 2. Exercise 2, question number 2. Question number 5. Try to get answers quickly, okay? These are not difficult questions. Exercise 2, question number 2, question number 5, and question number 11. I know some may find this difficult because we haven't discussed any question yet, okay? I usually give questions before teaching how to do a question, because that's where we start to think, okay? So I usually give some questions before teaching how to approach a question. Online students, you can check the group for tuts. I'll upload them again. You can find the tuts in the group. There is a note, that is note that we usually have to write in the class, but I usually print that to save some time. And you have the exercise tut. Go to the exercise tut. And in exercise 2, try question number 2, 5 and 11. Others who finish the questions can try to finish the whole exercise, okay? Just like don't waste time in the class. So if you are done with these 3 questions, just as soon as possible finish the whole exercises. It won't take much time if you know know the content. මේකේ මොකක්ද වෙන්නේ? දෙවෙනි එකේ they are asking for the resultant of these vector networks. මේ දෛශික පද්ධති වල සම්ප්‍රයුක්තය අහන්නේ. See, question number 2, exercise 2, question number 2. You can find one vector like this, another vector like this, another vector like this. Okay, now tell me, if the final vector was like this, if the final vector was like this, what is the resultant? Antima daishike mehema tibbana. If the final vector was like this, what would be the resultant? You have to complete the polygon, right? You have to complete the polygon. This is the starting point, this is the starting point, and this is the final point of the polygon. So you have to complete it. So this would be the resultant, clear? This would be the resultant, clear? The line that you draw to complete the polygon, clear? සමාන්ත බහුවශ්‍රය සම්පූර්ණ කරන්න අඳින රේඛාව නේද සම්ප්‍රයුක්තය කිව්වේ. But now what is the problem? Now what is the problem? Problem is this length is 0, right? Why? Vector 1, vector 2, vector 3 and vector 4 goes all the way up to this point. අන්තිම දෛශිකය මෙතෙන්ට වෙනකන් යනවා නේද? That means there is no line to continue the polygon, right? You don't have to draw anything to complete the polygon, clear? බහුවශ්‍රය සම්පූර්ණ කරන්න මුකුත් රේඛාවක් අඳින්න නැහැනේ. So that means you don't have a resultant. That means you don't have a resultant. You can't complete the polygon. Why? You have nothing left to complete the polygon. බහුවශ්‍රය සම්පූර්ණ කරන්න අඳින්න මුකුත් නැහැ. That means, okay, that means you don't have a resultant. සම්ප්‍රයුක්තය බිඳුවයි. It's like, I mean, it's obvious, right? It's obvious. Why? Assume that a person moves 500 meters this way, 500 meters this way, 500 meters this way, then again 500 meters this way. What is the actual displacement? 0, right? No change. වෙනසක් නැහැ නේ. ඇත්තටම එයා කොහෙවත් ගිහින් නැහැ නේ. මිනිහෙක් මෙතන ඉඳන් මෙතෙන්ට ගිහින් මෙතෙන්ට එනවා කියන්නේ පටන් ගත්ත තැනට වෙනවනේ. එහෙනම් ඇත්තට මුකුත් වෙලා නැහැ නේ. So if the polygon or the triangle, okay, if the polygon or the triangle completes by its own vectors, there is no resultant. බහුවශ්‍රය හෝ ත්‍රිකෝණය සම්පූර්ණ වෙනවා නම් එයාගේ දෛශික වලින් සම්ප්‍රයුක්තයක් නැහැ. තේරුණාද? You don't have, there's nothing to, if there's nothing to complete the polygon, that means there's no resultant. Clear? But you have to, sometimes you have to be careful. Let's move to question number 5. Question number 5. You have a network like this one, then this one, then this one. Again, I'll break this diagram into 3 pieces, okay? I'll break this diagram into 3 pieces. This one, now please do understand this, okay? This diagram is also completing, right? That doesn't mean this is 0, okay? I mean, if you have a diagram like this, this one, then this one, this is not 0, okay? First of all, understand that. This is not 0, make a bindu anime. Hey, why? See the directions. It's not moving like this, this and this. If it was moving like this, it is 0, clear? Eka mehema rawumata giya nan eka binduwai. But it's not actually moving like that, right? Eka ඇත්තට මෙහෙම නෙමෙයිනේ යන්නේ. So this is not 0, okay? What is the actual result of this one? What is the actual result of this one? You have to break it into 2 parts. This one and this one. Clear? What is the resultant of these 2 vectors? මේ දෙන්නගේ සම්ප්‍රයුක්තය මොකක්ද? What is the resultant of these 2 vectors? This one. Clear? This one. Now you have 2 equal vectors. Clear? Now you have 2 equal vectors. මෙයාගේ සම්ප්‍රයුක්තෙත් මෙයා තව එක්කෙනෙකුත් ඉන්නවා. So sum of these 2 is the resultant. Clear? Sum of these 2 is the resultant. Clear? So just completing the diagram is not enough. You have to check for the directions, okay? අර නිකන් පින්තූරයක් විදියට සම්පූර්ණ වෙලා තිබ්බා කියලා ඔක බිඳුවයි කියන්න එපා. තේරුණාද? දිශා බලන්න. තේරුණාද? Clear? So here we have to consider that, okay? That's why I divided it into 3 diagrams so that it's easy to analyze. මේක තේරුම් ගන්න ලේසි එතකොට. Why? This is one polygon that I have to continue. This is one triangle that I have to continue. This is one vector. Clear? What is the resultant of these 3 vectors? මේ දෛශික තුනේ සම්ප්‍රයුක්තය මොකක්ද? What is the resultant of these 3 vectors? This one, right? Clear? Resultant of these 3 vectors, this guy. Clear? පැහැදිලිද? What is the resultant of these 2 vectors? Complete the triangle. ත්‍රිකෝණය සම්පූර්ණ කරන්න. What is the resultant of these 2 vectors? This one. Okay? Now you considered the resultant of these 3 vectors, okay? So you have to forget this part. You can forget this part. Now you took these 2. That means you forget this part. Now actually in the system you have this one, and this one. Clear? Sum of these 3 vectors, you get the resultant from sum of these 3 vectors. Clear? මේ තුන් දෙනාගේ එකතුවෙන් තමයි ඔයාලට සම්ප්‍රයුක්තය ලැබෙන්නේ. Clear? So how can you write it? How can you write it? They have given us notations A, B, C, D, then E. Clear? So now you have, this is AD, right? you have 3 AD vectors. You have 3 AD vectors. AD දෛශිකයම තුන් පාරක් තියෙනවනේ. You have 3 AD vectors. That means the resultant is 3 AD. Resultant is 3 AD. Clear? සම්ප්‍රයුක්ත එන්නේ මේ තුන් දෙනාගේ එකතුව. තුන වැඩි කිරීම AD. පැහැදිලිද? Clear everyone? This is the resultant of these 3 vectors. Next one. Question number 11, right? Question number 11. If you need, you can write it down. Others try to finish the exercise. And meanwhile, I'll give you a little question, little bit different question. People who finish this exercise can try that question. Next, I'm going to discuss question number 11. Before that, I'll give a question for others. Okay, something to add, something to teach before that. Okay, first write this down. I mean, these diagrams doesn't need not to be clean or nice. Okay, just draw something as soon as possible. Don't waste time for this. And you don't need a ruler to draw these kind of images. Okay. It's good that your papers must be neat when you're writing anything. Okay, we usually train such things in paper classes. But, you don't need a ruler to make things neat in a diagram like this. Anyways, so one thing to add, if you have a vector like this, okay, if this is vector A, okay, if this is vector A, wait, I'll give that question after teaching parallelogram law. I think it would be nice if I teach it after if I give that question after vector parallelogram. So, okay, I'll first finish question number 11, then move to vector parallelogram. It would take like 5 or 10 minutes. Then I'll give this question. Then it's easy to approach that question. A small question that you have to think a little bit different. So question number 11, I think you had enough time to write, right? Okay, and at the end of the day, at the same time, try to draw the diagrams as fast as possible. Try to write the notes as fast as possible. Why? You don't have a separate training session to make things speed. Okay, you will never get a time to learn how to write, anything, maybe calculations, writing, anything. You have to make them fast, on the way, in the class, when you are writing something in the school, when you are doing some questions. Okay, make calculations fast, make log calculations fast, make your writing speed fast. Okay, do everything, learn everything in the class. Okay, because you have more than enough theory to learn. You don't have time to learn such things separately. ලියන එක ඉක්මනට ලියන්න ඕවා කරන්න වෙනම කාලවල වෙලාවල් හම්බ වෙන්නේ නැහැ. මේ ක්ලාස් එකේ ඉඳිම ඕවා ඉක්මනට කරන්න පුරුදු වෙන්න. තේරුණාද? Okay, question number 11. Question number 11. This is the vector network, this one, then this one. Okay, so this is the system. මේ තියෙන පද්ධතිය. So how to approach the question? Easiest way would be to divide this into small parts, right? මේක කොටස් වලට කඩා ගන්න එක ලේසි. I mean actually 2 parts. Why? Consider this one separately, then these two separately. Okay, Now you can see there are vectors moving from here to here, then here, same direction, then here, then again here. That means these vectors, these 1, 2, 3, 4, 5, 6, is it 6 or 5? 6, right? Yeah. These 6 vectors, it completes a polygon, right? මේ දෛශික 6 බහුවශ්‍රයක් සම්පූර්ණ කරනවානේ. They complete a polygon. That means you can forget those vectors. Why? Resultant of these 6 vectors is 0. මේ දෛශික 6 සම්ප්‍රයුක්තය බහුවශ්‍රයක් සම්පූර්ණ කරන හින්දා බිඳුවයි. Clear? Then you have only 2 vectors remaining. Okay, you have 2 vectors remaining. This point they call A, this point they call F, this D. So now you have only 2 vectors remaining, A to D, then D to F, A to D, then D to F. So what is the resultant? What is the result? Now complete this triangle. මේ ත්‍රිකෝණ සම්පූර්ණ කරා නම් හරිනේ. Complete this triangle. How? This is the resultant from starting point to this point. Clear? So what is the resultant? AF. Clear? AF vector. AF දෛශිකය තමයි සම්ප්‍රයුක්තය වෙන්නේ. Clear? Everyone? Clear? Okay. So working with vector triangles and polygons is quite simple. You just have to draw the diagram, understand what is happening there, remove unnecessary parts, then extract the relevant information, then complete the diagram. Clear? වැදගත් කරුණු ටික විතරක් එකෙන් ගන්න, පින්තූරයෙන් අනවශ්‍ය ටික අයින් කරන්න, වැදගත් කරුණු ටික විතරක් ගන්න, පින්තූර සම්පූර්ණ කරනවා. That's all you have to do. Clear? Everyone? Any questions up to this point? Okay. Online students, any questions? It need not, like, I mean, it's not 2AF, right? Like, student who asked the question, is it clear? It can't be 2AF, right? There's only one AF vector, right? There's only one AF vector. Why? All other vectors cancels out each other. Then only these two are remaining. Resultant of that these two vectors is this one. That means this line. Clear? There's a request to discuss question number 8. I'll discuss that and move forward. I'll discuss question number 8 and move forward for the vector parallelogram. Okay, here also answer is pretty simple, right? Here also what is the answer? It can't be 0, by the way, right? Only one vector remaining. එක දෛශිකයක් ඉතුරුයි. Why? Consider these vectors. This one from here to here, then here to here, here to here, then here, then here, then here. These vectors, they complete a polygon, right? මේගොල්ලෝ මේගොල්ලෝ ත්‍රිකෝණයක් සම්පූර්ණ කරනවානේ, බහුවශ්‍රයක් සම්පූර්ණ කරනවානේ. These vectors, they complete a polygon. Clear? So resultant is 0. You can forget this one, this one, this one, this one, and these two. Clear? මේගොල්ලෝම අමතක කරන්න පුළුවන්. Clear? Now what is remaining? This one, then these two. But now you have to consider the direction. See, it's not moving like this. Clear? ඒක මෙහෙම සම්පූර්ණ වෙන්නේ නැහැ නේ. It's not moving like this. See, direction of this vector is opposite. Clear? If it was like this, then you can consider that as 0. Clear? It completes the triangle, but it's not the case here. මෙතන එහෙම නෙවෙයි වෙන්නේ. So what is the notation? Notation is GE, right? GE. So you have one GE vector. Resultant of these two is this one. That means another GE vector, right? Clear? So the resultant is 2GE. Samprayukte enne 2 GE. Clear? Resultant vector is 2GE. Clear? Everyone? Okay. මේ තියෙන්නේ සම්ප්‍රයුක්තය 2 GE. Clear? The student who asked the question. The picture there is already a vector denoting AF. So which question? Question number? Question number? No, this vector. The question was the resultant of these two is AF. There's already a vector called FA. Shouldn't it be 0? No. Why? This vector was cancelled out by considering this polygon. When I consider this polygon, this vector was cancelled out. මේ බහුවශ්‍ය සලකද්දී යා නැති වුණානේ. So now you don't have any vector here. Only remaining vectors are these two. Clear? Okay. Next part. Vector parallelogram. දෛහික සමාන්තරාශ්‍ර නියමය. Vector parallelogram. What is a vector parallelogram? දෛහික සමාන්තරාශ්‍රයක් කියන්නේ මොකද්ද? It's same as the vector triangle. Okay. There's nothing new in vector parallelogram. දෛහික බහුවශ්‍රය කියලා අලුත් දෙයක් නැහැ. But this vector parallelogram is really useful to create equations. Why do we need to create equations? I සමීකරණ හදන්න ඕනේ. I mean, whenever you are continue using maths or assume that you have to calculate things related to vectors through a computer program or anything. To complete anything, you can't keep drawing images, right? To work with, when working with vectors, you can't keep drawing images, right? Okay, it's a useless thing. Assume that you have 100 vectors, you have to draw a polygon with 100 sides, right? So it's a pointless thing. Okay, so we need equations, mathematical equations to make things quick. Okay, make ඉක්මනට කරගන්න අපිට සමීකරණ ඕනේ. So to create these equations we use the vector parallelogram. අපි දෛහික සමාන්තරාශ්‍රය පාවිච්චි කරන මේ සමීකරණ හදාගන්න. So simple idea behind the vector parallelogram. You draw one vector like this. Clear? How do you complete the triangle? How do you complete the triangle? This is the first vector. Assume that you have two vectors like this. One like this, one like this. Okay? How do you draw a triangle for these two vectors? You start by one vector. Clear? එක දෛශිකයකින් පටන් ගන්නවා. And where this vector ends, you start the next vector, right? මේ දෛශිකය ඉවර වෙන තැනින් අනිත් එක්කෙනා පටන් ගන්නවා. Where this vector ends, you draw the next vector. Clear? Now what? Now what? Now you can draw a triangle, right? Now you can complete the triangle. You get the resultant. මේ තියෙන සම්ප්‍රයුක්තයනේ. You get the resultant. Instead of drawing this line, okay, instead of drawing this line, if you draw the second vector here, instead of drawing this line, if you draw this vector here, clear? මෙතන ඔය දෛශිකය අඳිනවා වෙනුවට මෙතන ඇන්දොත්, clear? When you complete this, you get what? A parallelogram. Or සමාන්තර රාශියක් හම්බ වෙනවානේ. This is vector parallelogram law, right? Nothing new. Same as vector triangle. Okay? What vector parallelogram law is? If you represent two vectors as two sides of a parallelogram. Okay? Two sides of a parallelogram which moves from the same point. එකම තැනින් පිටත් වෙන දෛශික මේ පාද දෙකක් විදියට සමාන්තර රාශියක පාද දෙකක් විදියට දෛශික දෙකක් ඇන්දොත්, okay, the diagonal of this parallelogram gives you the resultant. The diagonal of this parallelogram which moves through these two sides gives you the resultant. Clear? There's nothing new in the vector parallelogram law. දෛශික බහුවශ්‍ය දෛශික සමාන්තර රාශි ප්‍රමේය කියලා අලුත් දෙයක් නැහැ. Okay, instead of representing two vectors as a triangle, you use two vectors to draw a parallelogram. Clear? දෛශික දෙක පාවිච්චි කරනවා ත්‍රිකෝණයක් දිනවා වෙනුවට සමාන්තර රාශියක් අදින්න. Clear? So when you represent two vectors as two sides of the parallelogram, by this diagonal you get the resultant. මේ රේඛාවෙන් වාට සම්ප්‍රයුක්තය ලැබෙනවා. Okay, original definitions are included in your notes. Okay, so there's nothing new. Why? It's already like you don't even have to prove this, right? Why? This is a triangle. So okay, when you try to use the proof of the vector parallelogram is vector triangle law. Okay, දෛශික බහු සමාන්තර රාශි ප්‍රමේය proof එක වෙන්නේ දෛශික ත්‍රිකෝණේ. තේරුණාද? Okay, so instead of drawing a triangle, you use these two vectors to draw a parallelogram, then this diagonal gives you the resultant. මේ පාදෙන් වාට සම්ප්‍රයුක්තය ලැබෙනවා. පැහැදිලිද? But what is nice about this thing is, this parallelogram is, you can use this to create equations. මේක පාවිච්චි කරන්න පුළුවන් සමීකරණ හදන්න. පැහැදිලිද? That means let's consider a proper parallelogram. It doesn't look like a parallelogram, right? Are they parallel? No, right? Yeah, right? Okay. No. It should be inclined for a proper proof. No, I'll draw the parallelogram by myself. Okay. No. Okay, let's use this. It's parallel, right? Okay. Anyways. Okay. So this is a parallelogram, okay? Now, you have two vectors. You have two vectors called vector A and vector B, okay? Now assume this, okay? They give you these data, okay? I mean, when you are drawing the diagram, it's not a big deal. You just show them in the diagram, you get the resultant, okay? But in many cases, what we know is mathematical values. That means they give you this vector. That means they give you the magnitude and the direction. They tell you that there's a vector with a magnitude 5 which is moving towards this direction. Clear? And you know and they give you data about this vector. Maybe magnitude is 6, direction is this one, theta angle to the horizontal. Okay, that's how you usually get data, right? Okay, so you don't have a diagram. Okay, I'm drawing a diagram to prove this, but in many cases you don't have a diagram, but you know this data set about vectors. දෛශික ගැන මේ ටික දන්නවා. මොනවද? Magnitudes, okay, and directions. Clear? And usually we represent magnitude of vector A, we represent like this or simply like this. Okay, this is vector A. May A කියන දෛශිකය. Okay, this is not a value. Okay, this is a vector. If someone asks for the magnitude of this vector, මේ දෛශිකයේ විශාලත්වය වගේ අහුවොත්, okay, this is the symbol for that. Okay, this is the symbol for the magnitude of the vector. මේ තියෙන මේ දෛශිකයේ විශාලත්වයට අදාළ symbol එක. Clear? Or else you can simply write like this. Okay, now then you know that this vector, magnitude of this vector is A, magnitude of this vector is B, angle between these two vectors is theta. Clear? This data set you know. Okay, now what is the resultant? What is the resultant? Resultant is this one, right? Resultant is this line. Clear? We know that, right? We already know that. You need to find the length of this line. Why? You need to find the length of this line. Why? It would give you the magnitude of the resultant. Clear? If you somehow find the magnitude or the length of this line, it would give you the magnitude of the resultant. සම්ප්‍රයුක්තයේ විශාලත්වය හම්බ වෙනව නේද? මෙයාගේ දිග කොහොම හරි හොයාගත්තොත්. Clear? And if you somehow find this angle, you can represent the direction of the resultant. Clear? Angle alpha to the horizontal. Clear? So if you somehow find the length of this line and if you somehow find alpha, you can mathematically represent the resultant. Clear? Why? If you know the magnitude and the direction, that's all you need to know about a vector, right? විශාලත්වයයි දිශාවයි නේද දෛශිකයක් ගැන දැනගන්න තියෙන හැමදේම වෙන්නේ. එහෙනම් ඒ දෙක හොයාගත්තා නම් හරිනේ නේ, සම්ප්‍රයුක්තය හොයාගත්තා වෙනවනේ නේ. So we are going to create mathematical equations for alpha and the magnitude. I'll take this as R, resultant. Clear? R. So if this is theta, this must be theta, right? It's obvious, right? Clear? Same line. If this is B, this is B. Why? It's a parallelogram. Clear? Now I'll take this as X, this as Y. I can write sine theta equals Y over B, cos theta equals X over B. Clear? Cos theta equals X over B. So Y equals B sin theta, Y equals B sin theta, X equals B cos theta. මෙන්න මේ විදිහට එනවනේ. Clear? Now X is B cos theta, Y B sin theta. B sin theta. Now you can use the Pythagoras law. How? This is 90 degrees. If you somehow find this, I'll take this as P Q R. R squared means PR squared. Let's take it as S. R squared, that means magnitude of R. R is magnitude of R. R squared means PS squared, right? r squared means ps squared මෙයාගේ වර්ගය නේද ps squared means by Pythagoras law pq squared plus qs squared clear everyone what is pq a plus b cos theta a plus b cos theta squared plus what is qs b sin theta qs b sin theta squared clear this one you can write a squared plus 2ab cos theta plus b squared cos squared theta plus b squared sin squared theta this one b squared cos squared theta plus sin squared theta this is 1 right this is 1 we know that sin squared theta plus cos squared theta is 1 right sin varga theta dana cos varga theta එකයි කියලා දන්නවනේ in the first day we learned and by now everyone should know sin squared theta plus cos squared theta equals to 1 right so this one you can write b squared now clear so what is the final answer r squared equals a squared plus b squared plus 2ab cos theta r means a squared plus b squared plus 2ab cos theta root now see now you have an equation for the resultant සම්ප්‍රයුක්තයට සමීකරණයක් තියෙනවා you have an equation for the resultant but you don't have to draw any diagram right only knowing the magnitude of a and magnitude of b and angle between them is enough to find the resultant now you don't need any diagram right it's convenient to do these things without a diagram right පින්තූරයක් අඳින්නද උත්තරයට යන්න පුළුවන් නේ but is this enough no why magnitude of a vector is useless without the direction clear විශාලත්වය කියන එක තේරුමක්ම නැහැ නේද දෛශිකයක දිශාව දන්නේ නැත්තම් you only have the magnitude but if you find alpha somehow if you find alpha then you know the direction right why you can tell direction is alpha to the horizontal clear if you somehow find alpha කොහොම හරි හොයාගත්තොත් you know everything about the vector so let's try to find alpha it's not that difficult why you can write tan alpha clear using this triangle what is tan alpha b sin theta over a plus b cos theta b sin theta over a plus b cos theta clear this is tan alpha right b sin theta over a plus b cos theta then alpha means this is a mathematical notation if tan alpha is this alpha is tan inverse this is just a mathematical notation if tan alpha is this value alpha is tan inverse b sin theta over a plus b cos theta now you know both r and alpha that means you know everything about the resultant සම්ප්‍රයුක්තය ගැන හැමදේම දන්නවා කියන එක නේද මේකේ තේරුම you know everything about the resultant magnitude and the direction clear so we have two mathematical equations clear which we can use to find the resultant without any diagram කිසිම පින්තූරයක් නැතුව සම්ප්‍රයුක්තය හොයන්න පුළුවන් නේද දැන් සමීකරණ දෙකක් ලියලා that's why we use this vector parallelogram mainly but even for questions we use vector parallelogram okay to some like I'll give some questions okay Is this clear, everyone? Everyone? Okay, I'll give some questions, and if you have any questions, let me know. Okay. Uh, For these questions, you have to use vector parallelogram. Daishika bahuashya daishika samantarasya පාවිච්චි කරන්න. If you need, if you like, you can write something, okay? You have the notes so that you won't miss anything, okay? You would get the chance to completely forget about writing and focus, but that doesn't mean you don't have to write anything, okay? If you like, you can write. If you like, you can highlight. If you like, you can underline, okay? Do something with the note, okay? At the end of the day, if you can remember the equation, if you know the theory, that's enough, okay? So for some people, they only by focusing here, they can remember everything. For some people, by focusing now, and if you go home and read it one time, if you can remember, that's enough for them, okay? For some students, it may like they may need to create a short note from my note, okay? You can't create a short note from my note. It's already really short. So anyways, if you like to create, if for some students, they remember stuff by creating a note by themselves, okay? For some students, they remember stuff by highlighting, okay? Use your own way. I'm just providing notes to save some time, okay? And check your note, okay? Check whether the equations are correct, okay? If there are any issues with the equations, if anything is different than I taught, please let me know, okay? So like just go through the note when I'm teaching, okay? And check whether the equations are correct, or if there are any issues with the equations, let me know. So these are the questions that you have to try. Exercise 3. Part 1, question number 1 and 2. Then question number 2. Question number 3, I'll give you the question number 3, okay? First try these two questions. You can directly use the equations, like feel free to use whatever you like, okay? Use the equations or the parallelogram, okay? Anything. If you like, you can use the triangle. In the future, I'm giving you a lot of difficult questions. All the questions are open-ended, okay? Feel free to use whatever the method, and you can figure out by yourself what is the best method, okay? If I teach you these type of questions, you can use triangle. These type of questions, you can use equations. If you learn that way, you need me like to write A levels too, right? I mean, there's no option if I'm do the thinking for you. Okay, so when I'm giving open-ended questions, feel free to use whatever the method you like, and feel free to fail. Okay, feel free to fail, do multiple times. Okay, use different methods and feel free to fail. That's how you learn. Okay, you can figure out the best method by yourself. So another question, uh, there are two vectors a b. There are two vectors a b. If a plus b vector, if a plus b vector is perpendicular to a minus b vector, if a plus b vector is perpendicular to a minus b vector, uh, find the relationship between a and b. I think it's possible. Yeah, I think it's possible. I mean, even I'm not sure about some questions that I give. We have to be so. I mean, we can try and check it out. So the question is, a plus b vector is perpendicular to a minus b vector. එදන b දෛශිකය ලම්බකයි a ඍණ b දෛශිකයට. Find the relationship between a and b. Relationship of the magnitude. Okay. Yeah, I think it's possible. Yeah. Question number 3, you can get a relationship like regarding the magnitude. Question number 1, part number 1 and 2, question number 2 and question number 3. Try these questions. And like, please do understand, using the equation is not the only solution. Why? You learnt a lot about parallelograms. Okay, you learnt a lot about geometry, right? You learned a lot about the rules related to parallelograms. What are the relationship between diagonals? Okay, whether they are perpendicular or not. You know like there's a lot of rules that you learned in O levels, right? So if you draw diagrams, okay, if you draw diagrams, you can use all those theories you learned in O levels. Okay, theories related to parallelograms, theories related to other polygons, theories related to squares. Clear? You learn lot of properties of these shapes, right? A lot of properties related to these shapes. You can use those theories if you draw diagrams. Okay, so using the equation is not the easiest way out always. Okay, හැම වෙලේම ගාන හදන්න තියෙන හොඳම විදිය සමීකරණය දාන එක නෙමෙයි. මොකද O level කාලේ ගොඩාක් ටෙක්නික්ස් ඔයගොල්ලෝ ඉගෙනගෙන තියෙනවා මේ බිඳුර ගැන නේ. තේරුණාද මේ parallelogram එක ගැන, සමාන්තරාංශ ගැන, චතුරාංශ ගැන නේ. ඒවා යූස් කරන්න පුළුවන් ඔය පින්තූර ඇඳගත්තොත්. Yes, while you are doing these question, like these questions, I'll answer whatever the questions you have. So there's one online question and any other questions from like physical students. Anyone? ප්‍රශ්න තියෙනවා නම් කියන්න කට්ටිය questions කරන අතරේ මම ඒවට answers දෙන්නම්. Okay. So questions related to like online students. Yes, that question is correct. Like if you have A to B and B to C, and if there's already uh, yeah, I mean that's what actually happening. The question is if there's a resultant moving from A to C, and if there's already a vector going from C to A, whether the resultant is 0. Yes, that's what's happening here, right? I said that this is 0, right? I mentioned that if this triangle completes itself, it is 0. How? Resultant from A to B and B to C, you get as A to C, right? Resultant of AB plus BC. Resultant of AB plus BC is AC. Then you have another CA. You have another CA. You have one AC and CA, they cancels out each other. That's why this is 0. Okay? Is that clear, online students? Is that clear? Okay. So question number 1, part 1 and part 2 are quite simple. You just can use the equation. If P and Q are two forces acting at the same point inclined to each other at an angle theta, the resultant of those two forces is R. Alpha is the angle that P makes with the resultant. Okay. Based on the data given, use this vector as P, this vector as Q. Then they have the resultant. Angle between P and Q is theta. Angle between R and P is alpha. So question number 1, P is 12, Q is 12, theta is 90. What is R and alpha? It's simple. R is root P squared. We already know the equation. Q squared plus 2PQ cos theta, right? 2PQ cos theta. 2PQ cos theta. එතකොට එනවා මොනවද? P 12යි P 12 Q 12 plus 2P again 12 Q 12 cos theta. Cos theta is cos 90. Cos 90. So what is the answer? What is cos 90? 0. Cos 90 බිඳුවයි. Cos 90 is 0. Then you get root 12 squared plus 12 squared. That means 2 into 12 squared. You can take 12 out. Then you get 12 root 2. Clear? You get 12 root 2. Then tan alpha. You already know the equation for tan alpha. Q sin theta. Can you remember the equation? Q sin theta over P plus Q cos theta. Clear? This is the equation. Make the equation. So you have, what is Q? 12 sin theta, that means sin 90, theta is 90, sin 90 over P is 12 plus Q is 12 cos 90. 12 sin 90 means, sin 90 means 1, sin 91, sin 90 means 1. So you have 12 here. Here you get 12 plus 12 cos 90. Cos 90 is 0. Cos 90 බිඳුවයි. You get 12 over 12. Why? This is 0. This is 12. You get 1. You get 1. Tan alpha is 1. If tan alpha is 1, what is alpha? 45. Why? We know that tan 45 is 1, right? Tan 45, tan 45 එකයි නේද? So you can get the answer like this. Clear, everyone? So tan 45 is 1, so you have the answer. Clear? Let's try part 2. So it's nothing to teach here, okay? Just apply the values and calculate, okay? Part 2. What do I get? P is 3, Q is 5. Again same thing, right? P is Q. Okay, I'm not gonna do part 2. Why? P is 3, Q is 5, theta is 30. Find R and alpha. You have to do the same thing. Now there are different questions. Part 4, P50, Q120, R130, theta, and find theta and alpha. How? I'll move to part 4 of this question. Let's try part 4. You have P50, Q, P50, Q120, Q120, R130, R130, P50, Q120, R130. Find theta and alpha. So use the same equation, but now I have R, so I get the square of this equation. R squared equals P squared plus Q squared plus 2PQ cos theta. I need to find theta somehow, so I get cos theta equals R squared minus P squared minus Q squared over 2PQ over 2PQ. Then I get what is R 130 minus P 50 minus Q 120 again 2 P 50 Q 120. What is the answer? 50 squared plus 120 squared. Is it 130 squared? No, right? No, right? What is 50 squared plus 120 squared? It's is it 130 squared? I think so, right? Someone? Can someone do the calculation? 50 වර්ගය දන්න 120 වර්ගය 130 වර්ගය නේද? 5යි 12යි 13යි කියන්නේ Pythagoras values නේද? Yeah, right? 5, 12 and 13 means Pythagoras. It completes a Pythagoras triangle, right? So I think 50 squared, someone confirm. I think 50 squared plus 120 squared equals 130 squared, right? So I get 0. I get 0. Cos theta is 0. Cos theta 0 means what is theta? 90, right? So angle between these two vectors is 90 actually. Clear? Angle between P and Q is 90. Now I need to find tan alpha. For that I can use this equation, right? To find tan alpha, I can use this equation. Q sin theta over P plus Q cos theta equals, what is Q now? 120. Q එකසිය sin theta. Now I know theta 90. So sin 90 over P is 50 plus Q 120 cos theta, that means cos 90. Cos 90. Cos 90 is 0. Cos 90 is 0. Cos 90 බිඳුවයි. මට එනවා sin 91. Sin 91යි. I get 120 over 50. That means 12 over 5. To find this, you have to use the logbook or something. For in a case like this, you can just write alpha equals what? Just use the notation. That's enough. Tan inverse 12 over 5. Tan inverse 12 over 5. Clear? In a question like this, you can simply use this one. Clear? Tan inverse 12 over 5. Clear, everyone? Okay. Just use the equation again and again. Now what? Let's try this question, that question number 3 that I gave. Okay. Sorry, online guys. Like the camera's tracking feature is working now without notifying me. I mean, I try to play with the backend software of the camera to like add some features. Now I have ruined the original software. So there are a few issues that I have to clarify before that. I mean, we usually destroy a lot of technical stuff. Like I have destroyed one of my headphones. I tried to add some features and now it's not working. It was like I bought it for like 2 lakhs or something like that. Just only nice headphone, and I played with some features. Now it's not working. So this one also I may have to buy a new one. We'll see. So that is the reason. That's why it's suddenly it starts tracking me. Officially in the app I have disabled tracking, but since I have ruined the software and all, now I have to figure out a method to like rewrite it or something like that. Okay. Is this clear, everyone? Okay. Now, anyone questions, online students? Like, can someone reply with a text? Did you understand everything up to now? Or miss anything? Online students? Nice. So, I'll try question number 3. We'll see this one. A plus B is perpendicular to A minus B. Anyone need time to write this one? Anyone need time for this one? No, right? Okay. A plus B, A minus B, you can definitely use the equation for this, and you would get the answer easily by using the equation. But let's try to draw the diagram and get the answer. Why? I think it's better if we learn how to use the theories that we have learned in all levels, how to use them in questions. We'll see. I think it's possible to use a theory like that here. අපි O level ඉගෙන ගත්ත theory එකක් මේක use කරන්න පුළුවන්. How? Let's use vector parallelogram. දෛශික සමාන්තර අන්දිමු. හොඳට බලා ගන්න. You have A plus B. This is vector A. Focus. This is vector A. Okay. මේ A දෛශිකය. Clear? This is vector B. This is vector B. Clear? What is minus B? Minus B is the vector opposite direction, same length, right? Minus B means vector with the same length but opposite direction. Clear? This is B, this is minus B, right? Clear, everyone? So I'll draw the parallelogram. What is A plus B? A plus B means the diagonal of this parallelogram, right? This is A plus B, right? This is A plus B. Clear? This is A plus B. What is this line? What is this one? What is this one? A minus B, right? Why? You have vector A here. You have vector minus B here. This is the parallelogram of vector A and vector minus B. This diagonal gives me the summation of vector A and vector minus b මේකෙන් මට හම්බ වෙන්නේ a දෛශිකයයි ඍණ b දෛශිකයයි එකතුවනේ. This parallelogram gives me the summation of vector a and vector minus b. Clear? That means I get the answer as a minus b. Clear? So this is a minus b. This is a minus b. This is a plus b. Clear? This is a minus b. This is a plus b. Clear, everyone? Now, if this is a minus b and if that is a plus b, what they are telling is a plus b is perpendicular to a minus b, right? What they are telling is a plus b is perpendicular to a minus b. A ධන b a ඍණ b ට ලම්බකයි කියලානේ කියලා තියෙන්නේ. A plus b and a minus b are perpendicular. Now this is b. Length of this line is b. Again parallelogram. If this is b, length of this line is also b. Clear? Now see, my question is relationship between a and b. This is a, this is b, again b. Now see, this is a center. I'll draw this center like this. You have length b here, length b here. Clear? B and b. And you have a 90-degree angle like this. You have a 90-degree angle like this. A means this line, right? A means this line. Clear? You have b, center, then b. Then you have a, this is a. Then you have 90 degrees. What is this? A circle, right? Isn't this a circle? In a circle, if this is the diameter, okay, can you remember you learned something in O levels? Okay, can you remember you learned something in O levels? If this is 90 degrees, okay, if you draw this kind of a diagram for a circle, you get 90 degrees. That's how you learned it in O levels, right? Okay, if you use the diameter and if you complete a triangle using a circle, you get 90 degrees here. වෘත්තයක් අරගෙන එයාගේ විස්කම්භයේ ඉඳන් මෙහෙම ඇන්දොත් මෙතන 90යි කියලා ඉගෙන ගත්ත මතකද? Clear? I can't actually, like, I can remember the correct way you mentioned it in all levels, but can you remember you had something like this? Okay, if this is the diameter, okay, if this is a circle, this angle, if you use the diameter to draw a triangle, you get 90 degrees here. මෙතන 90ක් හම්බ වෙනවා නේද? වෘත්තයක විස්කම්භයේ ඉඳන් රේඛා දෙකක් ඇන්දොත්. මතකද? Then this is the center, this is b, this is b. It is the radius, then definitely this is b, right? It's the radius, right? Everywhere. Clear? You have the radius. Clear? That means a is equal to b. This was a, but it is b. A is equal to b. Why? Both b and a are a radius of a circle that you can draw like this. මේ විදියට අඳින්න පුළුවන් වෘත්තයක, මේ විදියට අඳින්න පුළුවන් වෘත්තයක, මේ විදියට අඳින්න පුළුවන් වෘත්තයක අරය තමයි a සහ b කියන්නේ. Clear? A and b are A and b both are the same radius of a circle. Clear? A කියන්නේ b කියන්නේ මේ වෘත්තයේ අරය. තේරුණාද? So always, I mean, you may get the answer quickly using the equations here, but the basic message that I need to pass is only solution is not the equation, okay? Because you did this equation is new, okay? This equation you learned in O levels A levels only, right? It's completely new. But features of a parallelogram, okay, features of a polygon, features of a square, okay, features of a circle. These things you learnt a lot, right? මේවා ගොඩාක් ඉගෙන ගත්තනේ. So you can use them if you decide to go use the graphical methods, okay? So whenever you get a question now, okay, ප්‍රශ්නයක් හම්බුනාම, now you don't have a clear idea about what is the best method, okay? You are just starting. Now when you get a question, try a graphical method. Try the equation. Try to figure out what is the best method, okay? When you do this in like 10, 20, 30 questions, okay, when you repeat this with 10, 20, 30 questions, then you like learn how to figure out the best way without starting the question, okay? Then with time you will figure out a way to find the best method before starting the question. Until then, like, use different methods, try to be like innovative with the equations, okay? Try to derive different equations, try to use different properties like this, okay? Just play with the questions, okay? That like just නිකන් අර හිතන්න එපා, like if I get a question in this category, I use this method. If I get a question from this category, I use this method, okay? I mean, it's not physics, okay? It's not physics, okay? So I mean, you have to do accounting or something, like if you need to follow the definite rules, okay? Because you can't invent anything in accounting, okay? It's a crime to invent stuff in accounting, okay? It's a crime to invent stuff in law, okay? But physics, it's all about inventing something, okay? So try to figure out your own methods, okay? Try to figure out your own methods. That's how you start thinking. එහෙම තමයි හිතන්න පටන් ගන්න, okay? This is a subject that you have to invent your own stuff, okay? I'll give you one more questions. Like I had to discuss this one too. I had to discuss exercise 2, question number 2. I'll give you another question. Anyways, I had to discuss exercise 3, question number 2. Then I'll give you another question. This one also, I'm not sure whether there will be an answer or not, but I think, yeah, it's possible. I mean, if I think, like, if the question is not from the note, I just think the question and give you. So on the way, if you feel like you need more data, please let me know, okay? Because there's a high probability that you need more data, okay? So if you figure out, like, on the way, if you figure out I need the angle or something like that, just inform me, okay? Just don't think that the question is right. Question is, angle between resultant of P and Q is R. Resultant of P and Q is R. Angle between P and R is 2 alpha. Angle between P and R is 2 alpha. Now, resultant of 2P and Q is R dash. Angle between 2P and R dash is alpha. Angle between 2P and R dash is alpha. This is a difficult question. This may be a difficult question. P, you have Q, then you get R alpha. 2P, get alpha. Yeah, I think question is correct. Find a relationship between the magnitude of P and the magnitude of R. Find the relationship between the magnitude of P and the magnitude of R. After that, try question number 4, exercise 3, question number 4. Try exercise 3, question number 2, then this question, Then exercise 3 question number 4. You have vectors P and Q. Again the question, I mean my suggestion is use vector parallelograms. Okay, use vector parallelograms here. uh, Resultant of P and Q is R. Angle between the resultant and P is 2 alpha. Yeah, I think correct. Yeah. Then you have the vector 2P and Q as R dash. Resultant of vector 2P, 2 into P and Q is R dash. Angle between this R dash and 2P is alpha. Find the relationship between P and R. That means you have vector P, vector Q. Resultant of them is R. Angle between P and R is alpha. Then you have vector 2P, Q. Resultant of 2P and Q is R dash. Angle between 2P and R dash is alpha. This is 2 alpha, sorry. This is 2 alpha. This is alpha. Find the relationship between R and P. Find the relationship between R and P. You don't need this part, but I just explained the question. Okay, you can come and try, like you can get the interval and try these questions. Time is 5. You can take your interval until 5:15, I think, like around 5:10 or 5:15. Okay, then you can try these questions. Okay, clear? I'm starting the discussion exactly at 5:15. Clear? check. Do we have the answer for this? This one? Yeah. What is the relationship between R and P? R सभी अतर संबंध है. What is to P? Let's check. Any answers? Relationship between R and P? Yeah, I got the answer from here. උත්තර තියෙනවා. බලන්න එක එක විදි වලට diagrams ඇඳලා බලන්න. Okay. And again, like there were some questions regarding like especially students who are doing sports and extracurricular activities. I think these questions were raised like in the beginning of the class too, like how to manage things with these things, like how to manage your extracurricular activities with these things. Like it's a very common question that we usually get in Sunday class also. There are a lot of students who are facing a lot of issues because my class is on Sunday. I mean, you have practices, tournament and everything on Sunday, so they are facing some issues with my schedule. But anyways, like some students have missed several lessons, so due to different reasons some students are facing a lot of issues due to like extracurricular activities. I mean, my suggestion is never stop them. Okay, you don't have to stop any kind of extracurricular activity you are doing. Okay, even I captained my school, Ananda College. I was the captain table tennis, and I was in junior national team wushu, and I were in many other like extracurricular activities while doing A levels. Okay, I mean, today I'm here because of that. Okay, I mean, I'm capable of running two of my own, one electronic company and software company, and I'm in the University of Moratuwa final year, and I'm teaching. I have a lot of classes, so the capacity to do all these things parallelly, it's definitely from sports and extracurricular activities. You can study whole 2 years, you would not get that experience like from education. Okay, our education system is not made to teach such stuff, so definitely keep whatever you are doing, keep them, but you have to understand your values. Okay, your values in the sense, don't like we usually do the sport, we keep the next step in our sports or extracurricular activities for recognition, right? I mean, many students do the sport, but one of your main dreams is to go on a tour. Okay, but sometimes you go 4-5 tours in when you are doing A levels, then you are done with A levels, right? Okay, sometimes you can go for the junior national pool, but you know that if you get selected for junior national team, then you are done with A levels. You have 5 days practice. So and also you are doing great in your sport, and you need colors. To get colors, you have to play the next year. That means A levels year. So one thing you have to learn is like sports and extracurricular activities are really important to improve like the person. But these colors, these awards, nothing matters when if you are doing engineering. I mean, if you are doing medicine, no one cares, right? Anyways, what are the sports that you have done? Okay, we don't ask for a doctor what are the sports you have done. No one cares, right? And especially in engineering also, nobody cares. Nobody cares whether you have gone like the skill set that you develop by doing a sport. It's really important. Okay, but whether you got colors, whether you were selected to junior national team, like these kind of things, they never care. I mean, like many of the values that you have today, like you won't care in 3 years. Okay, I mean, take me for an example. Like at your age, we like to drive our own vehicle, right? I have my own vehicle at home parked. Okay, because I have more than enough work now, I don't feel like driving. and I take a Uber always to the institute, to everywhere, right? I like to use Uber. Like, I mean, when I was in your age, like driving my own vehicle was a dream. It's really cool. But now I don't care, okay? I don't care. Uber is the best thing. Why? You get a driver, okay? You get the driver. And also, like, I mean, everything is like that, okay? Using a nice mobile phone, it's something really important like these days. But now, see, my phone, I think 2 or 3 years old. Okay, it's not that I don't have money to buy a mobile phone, but it's really hectic to move from this phone to another phone, right? I mean, you have to waste like 2-3 hours to move all the content in this phone to other phone. I mean, I don't like that process. So I'm really my this phone is more than enough for me. I mean, I mean, I have lost last two mobile phones, so definitely I will lose this someday. Then I'll be buying the next mobile phone. So, like, many things like colors. Okay, like, we like to get colors, like school colors. It's really important, to be the president of the society. Lot of values that you value today, lot of values that you think that are valuable today. I mean, nothing is important within like 3-4 years, okay? But the skill set, don't get me wrong, okay? I'm not asking you to stop societies and sports. I'm not telling that sports and societies are useless. No, the skill set that you develop in societies and sports is like 10 times more important than the content that you learn in A-levels. But just don't waste too much time to be the president, okay, of the society. Just don't waste too much time to get colors, okay? Just don't waste too much time to get selected to the national team or junior national team, okay? Those titles, nobody cares. I mean, I have a CV, you know, right? In my CV, it has like 5-6 pages. What I have done in academics, what I have done in engineering. When I go for anything regarding engineering, they never turn to the last page where I have all my extracurricular activities. They don't care, okay? That page is usually useless, okay? They never turn to that page. So whatever the qualifications you gain by doing sports, whatever the qualification you gain by doing extracurricular activity, nobody cares, okay? Nobody cares. The skill set you developed, yeah, it's definitely important. So, like, try to understand what I'm trying to tell. Like, societies and sports are important. You have to definitely keep doing that, okay? Otherwise, I mean, it's pointless. Just like, if you only thing you are capable of, if the only thing you are capable of is, I mean, you may be a good engineer, but someday after like 1 or 2 years after being an engineer, you have to go to the management level, okay? Then you will never reach the management level if you don't have that skill set that you usually learn from societies or sports or anything, okay? So it's really important, but never I mean, society never wastes the time, okay? Being the president, then you are in trouble, right? That's what usually happens, right? Being in the society, no big issue, okay? You learn, you enjoy, you meet friends, it's nice. Next year in the A-level year, you need to be the president. Then you're done, okay? That you know, right? So sports also same thing, right? You are doing this sport, you are playing your tournaments, you play whenever you have time, you play a private tournament, you maintain your national ranking. It's nice and it's enjoyable, right? But next year you get selected to the national team in the A-level year. Then you are done. You have 5 days of practice. I can remember I didn't participate for junior national. I mean, I was in the junior national pool mainly. Like, there was a tour for, I mean, there was a tour, Wushu, there was a tour in Malaysia or something like that. And I didn't participate that competition. The reason was, in the junior national pool, we had 4 days of practices. Okay, 4 days of practices in the sense, like, in the morning we had 8 to 12 practices. Like, there were like 20 students. Practice was coordinated by Sri Lankan Army. Okay, I mean, 3 guys fainted on the way. Okay, 3 guys fainted on the way. Then by 12, I think it's over. I mean, I'm already done. Okay, 3 guys fainted in the practices in the morning session at 12. Okay, guys, now, like, they called us, now you can take lunch. I think it was over. Then you can return by 1 p.m. It was 12 p.m. We were already done. 3 guys have already fainted. And then by 1 p.m. we can start our practices again. Okay, I mean, so I participated. I mean, if you get selected for the next team, next tour, how the hell I'm going to continue with A-level? So at that point, I have to know that I had a dream to go for, like, win towards everything. Okay, whenever you are doing sports, those are your dreams, right? Not participating in just normal tournaments, going for tours. These are the kind of dreams that we have, right? But I mean, if I keep that step to go through the next tournament, then A levels is, I mean, I can't do A levels, right? So in the decision making process, okay, in the decision making process, keep this thing in your mind. Whatever the values that you are earning these days related to sports, maybe anything, okay, whatever the values that you go after these days, they doesn't matter, okay. Nobody cares in engineering field, okay. I mean, I was the captain of Ananda College captain table tennis, but I mean, they don't need me to, in an engineering company, they don't need me to play table tennis, right? They need me to do engineering, right? So definitely, I mean, just point my ability to play table tennis, the fact that I was the captain of my school, nothing matters, right? They don't care. They need me for engineering. But how am I performing in that company? When I become a manager, how I'm going to perform? Definitely my sport will help, but they don't care. Okay, so just the how you decide things is do the sport, stay in the society, make friends, enjoy, but just don't go after titles, don't go after dreams like the dreams we have today. Just don't go after such things. I mean, definitely if you're planning to do great in your sport, if your target is to be good at that sport and sport only, just give up this thing and do your sport at your best, okay. If you read musicians, give up A levels, what the hell you are doing here, just go and play music and try to be the best musician that you know. But at the end of the day, if you are choosing to do this thing to be an engineer or a doctor or anything, then stop going after titles related to sports or music or societies, okay. That's how you make the decision, okay. So your decision making process is really crucial in this case, okay. Just some facts so that you have enough pointers to take the next big decision, okay. Okay, I mean, why this year you have to be the president or the sport? These are the years, right? You have to be the president or the captain or these kind of things appear. At least if it is this year, it's okay. In many schools, they give the captaincy and president everything in A level. See, I mean, even at least like Royal College, they give the prefectships after, like senior prefectships after A levels, right? I mean, in my school, it's not the case, right? In Ananda College, it's not the case. You become prefects and senior prefects in A levels years. So you become the prefect, you be the prefect, and if you become a great prefect, then most probably you're going to lose A levels, okay? If you do good in A levels, there's most probably are going to fail at that thing, right? So some schools, I mean, even in our times, not our times, 4 5 years before us, Ananda College top board used to be in like everyone, like 90% of them were able to select for medicine, engineering, and whatever they were doing. Like it was a really great top board, okay. I don't know now what is happening, so I can't give comments, but I see it decreasing with time. I saw that, but now I don't know whether it has improved or not. Now I don't know the state, but the top board that we saw in my school, it was great, okay. It was great. They were doing everything possible, okay. You may have heard Sabindu Herath, people like that, okay. They were doing great and they were selected to engineering, and they were doing everything great. But now it's not the case. Every school is like sports societies, prefectships, everything is going the other way, right? Like nothing's improving, nothing supporting you to improve the academics, right? So it's up to you, okay. It's up to you. These are like, I can't explain, like I can't take the decision for you. Why? Many students, even today, like students ask me to take the decision. It's not possible from my side, but these are the pointers, okay. That's how you take the decision, okay. Yeah, so let's continue. I'll start with this one, okay. මෙයාගෙන් පටන් ගන්නම්. Okay, there are some other questions. I'll answer them later. This one, I got the answer. I got the correct answer. We'll see. Easiest way is like you have two sets of data. Okay, you have two sets of data. The problem is alpha. Here you have alpha, and here you have 2 alpha. Here p. Here you have 2p. Okay. So the problem is when you have all these data, if you draw two diagrams, okay, if you draw two diagrams, how can you compare? Okay, here you have 2 alpha, here you have alpha. If you draw two diagrams, okay, if you draw two separate diagrams, මේවට පින්තූර දෙකක් ඇඳගත්තොත් ඕක compare කරන්න බෑනේ. So why not, why can't we draw one diagram for this? අපිට මේකට එක diagram එකක් අඳින්න බැරි. Like this. Okay, this is the diagram that I need. Why? This is P. This is P. Okay, this is Q. This is Q. What is the resultant of P and Q? This one. Resultant of P and Q. This one. Clear? මේ තියෙන P ගේ Q ගේ සම්ප්‍රයුක්තය. Resultant of P and Q. This one. Clear? Then this is 2p, right? Clear? This is 2p. Why? P plus P. Clear? This is 2p. Then this is Q. Isn't this the parallelogram related to 2p and Q? Clear? This is the parallelogram related to 2p and Q, right? Clear? This is the parallelogram for P and Q. Clear? This is the parallelogram for P and Q. P tie Q tie අදාළ සමාන්තර රාශිය මේකනේ නේ. This is the parallelogram related to 2P and Q. Clear? This is the parallelogram related to 2P and Q. Clear? 2P tie Q tie අදාළ සමාන්තර රාශිය මේක. Clear? Now so this is the resultant of, I have to draw it correct. Let's draw this one correct. Clear? Now see, this is the parallelogram for P and Q. Clear? So this is the resultant of P and Q, R. This is the parallelogram for 2P and Q. Clear? This is 2P. This is Q. This is the resultant for 2P and Q. Clear? This is the resultant for 2P and Q. Clear? Okay. Now, angle between P and R was 2 alpha, right? Can you remember? Angle between P and R was 2 alpha. Angle between 2P and R dash, angle between 2P and R dash alpha. And this is P. Why? It's a parallelogram. Make a samantarashya නේ. Make a P නම් මේකත් P. Clear? And if this is P, this is P. Why? It's a parallelogram. If this is Q, this is Q, and this is Q. Why? These are parallelograms. මේව සමාන්තරාශ්‍රය. පැහැදිලිද? Now, if this is alpha, what is this? Alpha, right? And if this is alpha, what is this? Again alpha, right? Can you remember? You had a law like that in, again, O levels, right? If this is alpha, මේකට නමකුත් තිබ්බ මොකක් හරි මතකද නැහැ. Okay, if this is alpha, right? Clear? Can you remember? එහෙමත් තිබ්බ කියලා මතකයි නඩුම තරමේ? Nice. Okay. So this is, if this is alpha, this is alpha. Now you have the answer, right? Now you have the answer. Why? This is a triangle. This is a triangle. Clear? This is a triangle. If this is alpha and this is alpha, R equals P, right? Again, you had a you had something like this in O levels, right? If these two angles of this triangle are equal, these two sides will be equal. Can you remember? I can't remember the names of these laws, but I can remember the idea. Can you remember? If these two angles are equal, these two sides must be equal. මේ කෝණ සමානයි නම් පාද සමානයි මතකද එහෙම තිබ්බා? So you can get the answer, right? R is equal to P, right? Alpha, so P equals to R. Clear? You will get a lot of questions, and definitely in papers also you will get questions like this. Okay, you have to like combine whatever you learn in A levels. Okay, and I mean, yes, if we need to keep students, and like if I need to grow this class, what should I do is giving questions that you can do. Okay, but I mean, it's pointless if the questions are doable. I mean, that means you are not learning anything. Okay, so definitely in our papers you will get a lot of questions like this, so you have to think one step ahead. Okay, පොඩ්ඩක් එහාට හිතන්න ඕනේ. This is not like, I mean, at the moment you may feel like these questions are difficult or something like that, but I mean, these are really simple questions. Like within 2 months, I can't do it alone. Within 2 months you guys must be able to handle these kind of questions. Like it's like a random summation or subtraction. Okay, these things must feel really easy. Why? The point is to improve your thinking capacity. Okay, when you improve your thinking capacity after a certain extent, these things you just see. Okay, you don't have to think. When you see the question, you see the answer. Okay, that's what we like try to achieve. Okay, that's what we try to achieve. But you should definitely give your maximum effort for this. Okay, you must give your maximum effort. How? Whenever you get a question, okay, whenever you get different questions, try different approaches. Okay, you get a question, try to draw a parallelogram, try to write equations, try to draw a triangle, try to draw circles, whatever you can. Okay, whatever you can, use these different methods. Okay, මේ එක එක වෙනස් methods ටික ඔක්කොම use කරන්න. Use different methods, then you can figure it out by yourself what are the best methods for different questions. Okay, ප්‍රශ්නෙන් ප්‍රශ්නෙට දාන්න තියෙන හොඳම විදිය ඕගොල්ලෝම හොයාගන්න. එක එක ප්‍රශ්න වලට හැම ක්‍රමෙම try කරලා තේරුණා? That's how you learn. Clear? Okay, let's try other questions. Everyone got this point? මේක පැහැදිලිද? Okay, next question. What is the next question? Question number 2. We'll see. Question number 2, exercise 3, question number 2. Exercise 3, question number 2. දෙවෙනි එක. If the square of the sum of two vectors of equal magnitude is twice the product of the magnitude of the two vectors, find the angle between two vectors. If the square of the sum of two vectors is the square of the sum of two vectors of equal magnitude. Okay, that means you have a vector P, you have a vector. Okay, you have a vector. Okay, yeah, like let me know. Okay, I usually put all aces to 19 as a habit, so just let me know as soon as possible. Okay. 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 Clear? I mean, අඩු කරන්න means temperature එක වැඩි කරන්න නේද? Yeah, okay. Let's continue. You have two vectors equal magnitude. Okay, you have two vectors equal magnitude. Two vectors but equal magnitude. That means if the magnitude of this vector is S, or let's take if the magnitude of this vector is P, magnitude of this vector is again P. Clear? Two equal vectors, two vectors with equal magnitude. If the square of the sum of two vectors of equal magnitude, that means What is the resultant of these two? What is the sum of these two? Can you remember the equation? R squared equals P squared plus Q squared, but instead of Q now you have P plus 2PQ. Here instead of Q you have P cos theta. Cos theta. Clear? P squared plus again P squared. Clear? Plus 2PQ, but you don't have Q, you have P here, equal magnitude. So again instead of Q you have P cos theta equals R squared. Can you remember this one? Just use in your official equation. What is the official equation? R squared equals P squared plus Q squared plus 2PQ cos theta. But instead of that, instead of Q we use P. අර සාමාන්‍ය equation එකේ Q වෙනුවට P දාපු එක විතරයි මේකේ කරේ. හරිද? Now they are telling this is equal to, okay? They are telling that this is equal to square of R is the summation, right? R is the summation. Square of summation is equal to is twice the product of the magnitude of two vectors. Is twice the product of magnitude of two vectors. Clear? Is twice the product of magnitude of two vectors. Find the angle. Now the question is simple, right? Why? You have 2p squared, 2p squared. You have 2p squared plus 2p squared cos theta equals 2p squared. Clear? Clear? These things cancels out. You get 2p squared cos theta equals 0. Cos theta equals 0. In the A-level marking scheme, definitely write this here, right? P is not equal to 0. Why? It's also a possible solution, right? If P is 0, this is 0, right? P bindu nam meka bindu ai ne. If P is 0, this equation will be 0, right? But what is the problem? If P is 0, the question doesn't exist, right? There's no point of talking about 0 magnitude vectors, right? So write this thing, okay? Write this thing, okay? You can't just conclude that cos theta is 0. Right conditions. අවශ්‍ය තත්ත්ව ලියන්න දෙරුණා. P බින්දුව උනත් බින්දුවයි cos theta බින්දුව උනත් බින්දුවයි ඒක ඇත්ත. Okay? එහෙම කියලා cos P බින්දුව වෙන්න බෑනේ. But mention that, okay? Mention that P can't be 0. These things are important in A-level marking scheme, okay? P is not equal to 0. So because of that cos theta is 0. Clear? Because of that cos theta is 0. So if cos theta is 0, what is the angle? Theta equals 90, right? Theta equals 90. If cos theta is 0, theta is 90. Next one, question number. I asked you to do question number 4, right? Clear? This one clear? Any questions? I asked you to do question number 4, right? Next. Or 5? 4, right? 4. Yeah. Try this one, question number 4. I mean, it's not like in measuring instruments, okay? We do a very small amount of theory and we do a lot of questions in mechanics, okay? It's opposite. Okay, there's a request. Yeah, I'll do that. Sure, I'll do that. Yeah, there are students who are doing IT with physical stream. Like there are questions related to that. I mean, yeah, it's good. I mean, now you have more AI, more IT. Then a lot of, I mean, government universities is not the only option, and I mean, going for university is not the only option at the end of the day, okay? Just don't forget that. I mean, I started working on my own company soon after A-levels. I mean, don't tell these things to parents, okay? But I mean, at the end of the day, sometimes, okay, if you are really capable, going to university is also a waste of time. Okay, just go and start doing something. Okay, work on your product. Okay, if you are good at electronics, work on your product. If you are good at software, work on your software product. If you are good at software, soon after A levels you can go for internship at a good company. Okay, you can ask us, we can give you internships. Okay, sometimes if you are really good at something, sometimes wasting 5 years at the university is also a waste of time. I mean, going for university is also a waste of time. We can think these things later. First we have to write A levels, and at the end of the day, just be, I mean, if you may be really capable, but if you fail A levels and you decide you are not going to university, it's not a flex, right? No one cares. But if you get selected for engineering and if you tell that you can't go for university, I mean, these things are pretty easy, I don't need to go to the university, then it's a flex. Okay, so first you have to do A levels at your best. Only A level currently. Okay, get 3 years, then tell that I don't want to go to university. Okay, ඊට කලින් කියන්නේ බව කවුරුත් ගණන් ගන්න පිස්සු කියලා හිතනවා. I mean, these questions, yeah, I agree that I don't give enough time for you to try. Don't worry, there's a lot of tunes other than this that you would get enough questions to try. Here, what I'm doing is giving some time to like understand the question, then I do the question so that you can see my approach. So you see different options that you can try with questions. That's my target. That's why I'm not giving enough time to try the question. If the resultant of two vectors of magnitude root 3f and 2f, if the resultant of two vectors of magnitude root 3f and 2f is perpendicular to root 3f, find its magnitude and angle between two vectors. If the resultant of two vectors of magnitude root 3f and 2f is perpendicular to root 3f. First we have to understand the question. We have vector root 3f. We have the vector root 3f. Then vector 2f. Then vector 2f. Resultant of these two vectors is perpendicular to root 3f. Okay. Attention here, everyone. Okay. This one you had enough time to write, right? Anyone writing this thing? No. Okay. So here you have vector root 3f And you have vector 2f, but the problem is understand how to draw these vectors. You have vector 2f and resultant is perpendicular to 3f, root 3f, clear? සම්ප්‍රයුක්තයේ මූල 3යි f ලම්බකයි. Resultant is perpendicular to root 3f. This is the resultant, clear? So definitely how can you draw other vector 2f? Definitely like this, right? Definitely like this. Can you understand? I mean, if you draw root 3f like this is how to understand. You have to understand this thing properly before drawing the diagram. පින්තූරය අඳින්න කලින් මේක හරියට තේරුම් ගන්න ඉන්න ඕන. If this is root 3f, okay, and if this is 2f, how can you draw a resultant which is perpendicular to this guy? මේ දෙක මෙහෙම ඇඳුවොත් මෙයාට ලම්බක වෙන්න මේක ඇඳ ගන්න බෑ නේද? If you draw root 3f and 2f like this, how can you draw r in a way that it's perpendicular to root 3f? Not possible, right? So here actually root 3f is moving this way, root 2f is moving this way, and you complete the parallelogram. Then you get this as the resultant. So that parallelogram is little bit different, clear? ඒ සමාන්තර ආශ්‍රය ටිකක් වෙනස්. පැහැදිලිද? You have root 3f like this, 2f like this. This is your resultant, clear? මේ වගේ සම්ප්‍රයුක්ත. පැහැදිලිද? So if this is the case, okay, now the question is මේ part එක හැමෝටම clear ද? Everyone? Okay, clear? Everyone? Why this is, I mean, they are telling that r is perpendicular to root 3f, r මූල 3f ට ලම්බකයිලු, r is perpendicular to root 3f. So this is the only way that you can draw a parallelogram, right? සමාන්තර ආශ්‍රයක් අඳින්න පුළුවන් එකම විදිහ මේකනේ. Now the question is find its magnitude and the angle between the two vectors. That means you have to find r, then you have to find this angle between two vectors. Clear? That is the question. Do we have enough data? First of all, I mean, we can definitely write equation for tan alpha, okay. I think writing the equation for this question would be easy. Or else, no, we have a easy method, right? Yeah, you can use the Pythagoras law here, right? Why? This is a parallelogram. Make a samantarashyak. This is a parallelogram. If this is root 3f, this is root 3f, right? Sorry. I mean, if this is root 3f, this is root 3f, right? Make a moola 3f now, make a moola 3f nede. Now this is a triangle, right? Clear? With the 90-degree angle. Clear? Then you can use Pythagoras law, right? What? Root 3f squared plus r squared equals 2f squared. Clear? Root 3f squared plus r squared equals 2f squared. Clear? Now you can find r. How? R squared equals, here you get 4f squared minus here you get 3f squared. Here you get 4f squared, here you get 3f squared. That means you get f squared. R squared equals f squared. That means r equals f. R equals F. Now you have the magnitude of R. R ge vishalatwaya tiyenawa neda? Now you need to find this angle. Angle between root 3F and 2F. Clear? මූල 3යි F උයි 2යි F උයි අතර කෝණය හොයන්න කියලා කියන්නේ. Why should I try to find this angle? I already know that this is theta. This is 90. So I'll take this angle as beta. I'll take this angle as beta. I already know that R is F. I already know that R is F. I can write sin beta. What is sin beta? Sin beta means this one over this one, right? Clear? Sin beta means root 3F. Sin beta means root 3F over 2F. Clear? Clear? That means root 3 over 2. If sin beta is root 3 over 2, what is beta? 60, right? I think 60 degrees, right? Yeah. I have asked you, you must remember these values, okay? I mean, at least if you can't remember, I'm not recommending you to study anything. Just keep a piece of paper with common trigonometry values, okay? Just keep a piece of paper. You do questions again and again, then you will eventually remember, okay? So just don't study, never study these things, okay? So sin beta, root 3 over 2 means beta is 60, clear? Then what is the final angle? Here, keep, like, don't start writing. What is the final angle? 90 plus 60. That means 150. Here also, I think, I mean, I should tell this. I mean, I didn't think before doing this. Okay, I mean, can you see, when writing sin, I took sin beta here. I always had the opportunity to get tan beta or cos beta, nothing related to this lesson, okay? I had the option to find cos beta, tan beta, sin beta, ඕන එකක් ගන්න තිබ්බනේ. But without thinking, I chose to go with sin beta. Why? Cos beta, this R was found by me. Okay? So there's some kind of a chance that I get this thing wrong. I mean, these things, when you have enough practice, we will do a lot of questions and papers. Enough practice, without thinking, you implement such methods. These, I mean, whenever possible, go with original values. Clear? Whenever possible, go with original values. Don't trust your answers. Okay? Go with original values. I mean, for a small question like this, why should you care? Okay? But I mean, these are the habits that you implement in questions which may go for like 4 or 5 pages. Okay? Sometimes in questions, when you start doing calculations, okay, A-level essay question, you may be doing the question in 2-3 papers. You keep writing answers. These habits are really important in such cases. Okay, why? First part you may get wrong, but if you have these kind of small habits, okay, you are not, whenever possible, you are not using your values. Okay, whenever possible, you are not using something you found. Okay, if you like use these habits, okay, there's your error probability goes down. Okay, your error probability goes down. Why? At the end of the day, in A levels, okay, I mean, there are, we do more than enough questions. We teach theory very well. So usually subject is not where you get wrong. Okay, usually you lose 20-30% marks due to careless mistakes. Okay, so implement these methods. These things you can't train when it's close to A levels. These things must be day-to-day habits. Okay, these things must be day-to-day habits. Whenever possible, I'm not using values found by me. Okay, very simple theory. Okay, so make these things like daily habits. Okay, whenever you are doing questions, try these things. Okay, because it's not important in small questions, it's really important in huge questions where you will get everything wrong if you go move forward with a wrong answer. But to make it a habit, you can use small questions. Okay, theta is 150. Now we have everything. Yeah, write it down, and if you have questions, let me know. I have one small part to teach, then I can like wind up for today. Next week will be, I have to do more questions related to motion, vectors. Then I'll be moving to motion. චලිතයට මාරු වෙයි අපි next week or ඊට පස්සේ week එකේ. And this Friday, okay, write this down, then I'll move to the next part. This Friday you will have 8 to 10 p.m. Not mandatory. If you are okay with measuring instruments, you don't have to join. Okay, but and anyways, I'll be providing the recording. Okay, so it's not mandatory, but if possible, try to join. I mean, whenever you learn things live, it's done, right? Otherwise, to watch a 2-hour recording, it takes like 5-6 hours, right? So it's, if possible, try to join live. So 8 to 10, I'll be discussing past paper questions, measuring instruments, past paper questions. I have already provided them in the group. I'll provide them again in the group. මම ආපහු group එකේ දාන්නම්. විනුම් උපකරණ past paper questions ටික අපි පොඩ්ඩක් discuss කරමු. වැදගත් ප්‍රශ්න ටික තීරි මතක් වෙන්නත් එක්ක. Okay. Next part. I mean, try to finish all the questions in the tute, but anyways, you will get a lot of questions again and again. I usually discuss these questions again and again every week. We usually take first hour. When I'm doing motion, I use the first hour or first 45 minutes to revise vectors, do questions from vectors. When I move to the next part, Newton's laws, I use the first half an hour to revise motion. That's how I usually proceed. So finish this exercise, all the exercises if possible. I'll be doing more questions from the exercises, and also I'll bring some revision tutes which you have difficult questions related to these areas. You can try them. Then we'll be again and again we'll keep discussing these kind of questions until you get really comfortable with vectors. Okay, දාශයක එක්ක සෑහෙන හොඳට වැඩ කරන්න පුළුවන් වෙනකන් අපි මේක කරන්න ඕනේ. Why? After that, we are using vectors again and again. Okay, we have acceleration, velocity, displacement. මේ ඔක්කොම මොනවද දාශයකනේ? When we are working with vectors again and again, we have to use these theories, but we are not teaching these theories again. Okay. So before moving forward, we have to be really comfortable with these laws. Okay. We have to learn how to work with vectors before starting to work with vectors. Okay, that is the idea. දාශයක එක්ක වැඩ කරන්න කලින් දාශික එක්ක අපි ටිකක් කම්ෆර්ටබල් වෙන්න ඕනේ. ඒකින්ද මම ඊළඟ කොටස් වලට ගියත් මේවා ආපහු ඩිස්කස් කරනවා මේවෙන් ප්‍රශ්න. Next part. Vector resolution. Vector resolution. දාශික විභේදනය. Okay. What is the idea behind it? මොකද්ද දාශික විභේදනය කියන්නේ? What is vector resolution? I mean, consider Google Maps. Okay? A person moves from here to here. From here to here. But they use XY coordinate system, right? Not actually the XY coordinate system, but something like XY coordinate system. Google Maps identifies a location using this coordinate system. They use the XY coordinate system for this. So you can't tell that this person moved this way. Like you can't tell that this person moved 5 meters this way. Okay. How Google Maps understands is the person was here, this was the x coordinate, this was the y coordinate. then he is here. This is the x coordinate and this is the y coordinate. Okay, to calculate anything related to this person, our like Google Maps requires this x and y coordinate system. Okay, that means Google Maps should know how much towards this distance and how much towards this distance. Clear? That's what we call vector resolution. Okay, effective impact of a vector, you divide it into parts such that it's easy to understand. Clear? අපි කරන්නේ මොකක්ද මේ දෛශික විභේදනය කියලා? එක දෛශිකයක් කොටස් කිහිපයකට බෙදෙනවා. තේරුණාද? I mean you moving from here to here and here to here is equal to moving from here to here, right? Clear? It's same, but this is more understandable by a machine. Clear? This is more understandable by a machine. For a person, this may be convenient, right? Okay, this may be convenient for a person. For a machine, this may be convenient. For in different scenarios, we need to represent the same vector by dividing it into smaller parts. එක කොටස් වලට බෙදලා ප්‍රකාශ කරන්න පුළුවන් නම් හොඳයි. So in our syllabus also, we usually divide vectors into x and y coordinate systems. Why? That is the official coordinate system we use in our syllabus. අපේ syllabus එකේ xy coordinate system එක Cartesian coordinate system, right? Cartesian එක නේ ඔකට කියන්නේ. We usually use the Cartesian coordinate system, right? I mean there are many other coordinate systems. Okay, you have spherical coordinate systems, you have cylindrical coordinate systems, you have Cartesian coordinate systems. Okay, in a spherical coordinate system, nothing related to the lesson. In spherical coordinate system, how we present a location is, I mean, let's take a cylindrical coordinate system. You have these kind of things in like especially in engineering. Okay, how do you represent a location? First you represent, this is angle 0. First you represent this angle theta. First you represent this angle theta. Then we know that it's somewhere in this line. Then you give the height. Then you know the exact location. See? We can use different coordinate system, but don't have to think about this. Why we use x and y coordinate system in our syllabus? අපි පාවිච්චි කරන්නේ xy coordinate system එක. For maths people, it's good to know these kind of things. Okay, you may get some questions related to these kind of ideas. මේ වගේ ideas එක questions එන්න පුළුවන්. Okay, here, so how to divide a vector into parts? If this is your vector, if this is the x component and if this is the y component, if this angle is theta, it's pretty easy, right? How? Y over r equals to sin theta. Y over r equals sin theta. X over r equals cos theta. Equals r sin theta. X equals r cos theta. So when you have a vector like this, what is the impact towards x direction? R cos theta. This direction, r cos theta. What is the impact towards this direction? R sin theta. Clear? So the basic idea is, that means if this is y, this is also y, right? This is x. So basic idea is, if you have a vector like this, you can divide it into two components towards x direction and y direction. If you have theta here, when you move through the angle, it's cos theta, r cos theta. When you move away from the angle to get this one, clear? When you move away from this angle to get the other component, it's r sine theta. Clear? You have r cos theta and r sine theta. That's how you get the resultant. Clear? That's how you divide the vector into different parts. Clear? So we learned. Is this clear, everyone? Clear? So we learned how to divide a vector into smaller parts. We learned how to add a vector, and at the end of the day we know how to subtract a vector. Why? I mean, subtracting means adding the negative vector, right? So subtracting means adding the negative vector, so no big issue with that. So yeah, next week, like plan from next week, I usually use the first hour of the class for like several weeks to revise vectors. We do a lot of questions. While doing that, next 2 hours I'll be using for motion equations. චලිත සමීකරණ චලිතය ගැන කතා කරන්න ඊළඟ කොටස මම පාවිච්චි කරනවා. That's my plan from next week onwards. And this Friday we have from 8 to 10. This Friday from 8 to 10 we have measuring instruments past paper discussion. If possible, please join. Okay, you are ready to go home, right? I was planning to do till 6:30. Okay, anyway, I think it's possible to do till 6:30, right? Every week. Okay. So for today, like, I mean, it's not good to disrupt the momentum. So I'll finish by now. Like, I mean, next week let's do until 6:30. Then we may have to move it up to 7 someday. Then, like, as I mentioned, this is not mandatory, but if you don't have a class after this class, please don't start a class. Okay? Why? Now I have a class for 25 batch students from 7:30 to 10, but we are doing 2 classes for 25 batch. We'll be finishing the syllabus for 25 within like 4 months. I mean, we are planning to finish syllabus for 25 batch before 6 or 7 months before A levels. Same plan I try to implement with you guys. Why? I mean, we finished syllabus before like 1.5 years before A levels. Okay, now it's not happening. That's why. So I mean, for you guys also, I'm trying to finish the syllabus before 6 months before A levels. So soon after, like when I'm done with 25 batch students, okay, I mean within 4 months I'm done with the syllabus. So if you need to, like, if you need me to revise previous parts, if you need me to do some additional questions, if you need me to start something from the end, if you like, we can start another lesson from the end, right? Maybe matter and radiation, something like that, which is not related with these lessons. We can use like 2 or 3 more hours after this class, if you like. Okay, so there's such a possibility if everyone doesn't have a class after this. So if you don't have a class after this one, please don't start a class. Okay, so for today I'll finish, and you have to try exercises up to I think this is not the vectors too. Yeah, finish exercise 3. Exercise 4 I'll discuss next week, and let's complete vectors. We'll be able to finish theory related to vectors by next week. Yeah, that's all for today. Thank you.